afternoon, my name is Gina and my teammates are Josanne Batson and Winton Pierson. Today we'll be discussing chain selection procedures. Chains have been used for many centuries to drive machines and transport materials over conveyors. The first instances of this technology has been seen in the Greek and Chinese cultures, in which they were used for weaponry and clock making. In the 1800s, the industrial age, cog chains were developed for power transmission, transportation, and agricultural applications. However, these chains were easily broken and very difficult to fix. In 1873, a solution for the cog chain was developed. It is called the cast detachable chain. The cast detachable chain is made of simple identical cast links that are easily coupled and uncoupled by hand if the chain is broken. Since then, the designs have been mostly unchanged in this field, since they are simple and practical. Now Josanne will speak about engineering class chains.
From a wide range of engineering class chains, we decided to focus on 5 types. They are drive chains, steel bushed chains, roller conveyor chains, cast combination chains, and flat top conveyor chains. First, we start off with drive chains. They are used to transmit power from one place to another, and this can be seen in the powering of the wheels of a vehicle. Then we have steel bushed chains, and these are ideal for operating under extremely gritty and abrasive conditions like cement manufacturing plants. Roller conveyor chains. These are used for applications that involve the transportation of heavy or bulk materials. Cast combination chains. These are used for transmission, conveyor, or elevating purposes. The inner links of combination chains are cast of malleable iron integrated with steel links. And lastly, flat top conveyor chains. Those are made of carbon steel, stainless steel, acetal, or low frictional acetal. And now we will look at selection procedures with Winton.
The selection procedure. There are many ways to select the chain to fit your mechanical needs. For different chains, different companies have different selection procedures. We will look at U.S. Sabaki Company on how they conduct their chain selection process for a drive chain. Step 1, determine class of driven load. As you can see, they use a table which is headed application classifications, which has different types of drive loads. It can be conveyors uniformly loaded or fed. It can be conveyors heavy duty, not uniformly fed. It can be dry dock cranes, elevators, laundry washers, laundry tumblers, line shafts, and different lumber industry parts, just to name a few. Step 2 is to select the service factor. They use another table which has the type of input power, internal combustion engines with hydraulic drive, electric motor or turbine, internal combustion engine with mechanical drive, and also the type of driven load which you get from step 1. That will give you your service factor. Step 3 is to calculate design horsepower. That is calculated by using the horsepower times the service factor that you got in step 2 will give you the design horsepower. Step 4, select chain pitch. Once you have your chain pitch, you can then go to step 5 and select the number of teeth in the small sprocket. Once you have your chain pitch and the number of small teeth in the small sprocket, you can then go to step 6 and calculate the number of teeth in your large sprocket using this equation above, which capital N is the number of teeth in the large sprocket, which lowercase r is the RPM in the small sprocket, lowercase n is the number of teeth in the small sprocket, and capital R is the RPM in the large sprocket. Step 7, determine suggested minimum center distance. Using this equation, C is equal to 2 times the number of teeth in the large sprocket plus the number of teeth in the small sprocket divided by 6. And that will give you your chain pitches. Step 8, check the final drive design. Be sure sprockets and chain will fit into the available space. Step 9, specify sprockets. Set the standard key weight and the screw dimensions in this step as well. And then you go to step 10, which is calculating the chain length, with the chain length is equal to the length of the pitches times the number of pitches. And that will complete your steps on selecting a drive chain. Now we will hand the conclusion over to Gina.
Chains have been in existence for many years. There are few technological advances in design and application in recent years. The chain selection depends on its application, and the procedures for that chain selection vary with each company. Thank you.